The Solar Podcast is brought to you by Continental Energy Solutions. I'm your host, Tim Montague. Today on the Solar Podcast, Hybrid Optimization and Performance Platform, aka HOPP. My guests today are two engineers from NREL, Aaron Barker and Parangat Bhaskar. Welcome to the show, guys.
Hey,
Thanks,
thank you,
Tim.
Tim.
Thanks for having us.
I'm so excited to have NREL on the show. That's the National Renewable Energy Laboratory in Golden, Colorado. It is the holy grail for renewable energy research here in the United States. So, really happy to have you guys on the show. And, hybrid power plants are all the rage. We see a lot of solar and storage or wind and storage. And there's obviously a need, which you are filling now, for modeling tools that will model solar, wind, and storage power plants at the utility scale. There are some tools for DG, like Homer, and we're going to talk about what are the differences between the existing platforms and your tools. So give our listeners some background and context, though, on how you guys came to the renewables industry and NREL. We'll start with you, Aaron.
Sure thing. Thanks, Tim. So my name is Aaron Barker. I've been in the renewables industry for about 10 years now. Originally wanted to be a lawyer, actually, for my sins, but that didn't play out. So I found a path through civil engineering, structural engineering, and then found renewables. And that's kind of where things clicked for me. So I worked in the wave energy technology space for about 6 years before moving to NREL. Have now been here for about 2 years, and I'm working exclusively on hybrid energy systems. So looking at wind, solar, and storage combinations and how to model, design, and analyze those systems.
Excellent. Thank you. And you, Parangat?
Yeah, thanks, Tim. Hey everyone, I'm Parangat Bhaskar. I grew up in India, and India had grown up. There was a lot of blackouts or brownouts in India, so I knew early on that power is going to be a huge part of my life. Trying to solve this power problem in India, and that's how I got introduced to renewables. And I knew back then that since computers were the biggest revolution in the previous century, I think renewables, green energy is going to be the next thing that we talk about. And that brought me to the U.S., where I got formally trained in energy systems engineering at Penn State. Worked in the microgrid industry prior to joining NREL, and here at NREL, I've worked with this system advisor model, SAM, tool as a software developer. And in my current role, I work with Aaron on hybrid energy systems. So we're developing techno-economic models that get fed into HOPP. So here we are.
Excellent. And here we are in 2021. It's heady days because the Biden administration has made it clear that they are really going to step on the gas when it comes to renewable energy and tackling climate change. So it's really heady days. There are estimates that we might be installing 800 gigawatts of solar in the next 15, 20 years here in the US. And of course, it's a both and. We need lots of solar, lots of wind, and lots of storage. Mostly today in the form of lithium ion, but there's, of course, hydrogen, gravity batteries, pumped hydro, closed loop pumped hydro. A lot of new and novel approaches to long-term storage are also emerging onto the landscape. So let's talk about HOPP. What is it in a nutshell, and why are you guys developing this tool?
Yeah, sure thing. I can tackle this and get the ball rolling. So back in 2020, Aaron and I were part of a DOE initiative where we interviewed quite a few people in the industry. We spoke with a lot of developers, researchers, and folks in academia as well. And we basically compiled a list of their pain points. And some of the main things that stood out were there's transmission constraints from high solar penetration in the grid right now, which is slowing down deployment of future standalone technology. Land procurement is getting harder. All the lowest hanging fruits have been taken, so finding the right piece of land for solar or wind is getting harder. And underperformance is impacting finance. KWH Analytics recently spoke about how solar is underperforming there's also been studies on how wind farms have underperformed as well. And mid and small tier developers are losing out to larger players. So these were some of the pain points that we sort of boiled it down to that industry is currently going through. And this is where I think I personally got interested in hybrids, and so did Aaron, and so did the rest of NREL's team that works on hybrids. Just at a 30,000 foot level, I think what hybrids are is a combination of one or more generation coupled with storage. So you could have wind plus storage, battery, or wind plus solar plus storage, or wind plus solar plus pumped hydro, for instance. It's a whatever combination you can think of, as long as there's a storage component and a generation component. That's what we call hybrids. And the charge of hybrids in our case, I think, which sort of addresses the industry pain points, is that hybrids offer optimal land usage. There's lowest costs per kilowatt because there's sharing of infrastructure between, say, a solar and wind farm. There's increased annual energy production possibilities, and a more smoother capacity factor, a higher capacity factor, because you're at this point sharing a complementarity of resources. Winds blowing at peak at night, sun shining at peak during the day. You combine those two resources behind a point of interconnection, and you're getting a very smooth power output on the other side. So all these advantages that we're seeing sort of don't answer all of the industry pain points, but they start to chip away at them. And I think hybrids are the fastest way to address these pain points. And not to mention, I guess, when you oversize a wind and solar farm behind a point of interconnection, either the wind's going to be blowing or the sun's going to be shining. So you're cutting down your probability of the system underperforming. So the reduced financing term, the bad financing terms that developers are getting today because of underperformance, that's also starting to get addressed with hybrids. So all that background, I think, that's what led us to develop HOPP, and I think. Aaron, if I can pass the torch to you, I think as one of the lead developers of HOPP, I think you do a good job of explaining what HOPP is.
Sure, thank you, Parangat. Yeah, so like Parangat mentioned, there are all these kind of pain points that hybrids are starting to address in the industry, and they have a lot of promise and a lot of potential, but with that comes a lot of kind of technical risk and a lot of considerations that need to be made. And with that, there's no real framework right now for developing these hybrid plants, for designing them, for optimizing them. Like you talked about, Tim, there is Homer at the distributed scale, but the system considerations there are a little bit different than the utility scale. So the aim with HOPP, the Hybrid Optimization and Performance Platform, was to make a platform for analyzing utility scale plants at the component level. Now, the component level means to us all the individual components of a wind farm. So the turbine and all the balance of plant, whether that's interconnection or erection or foundations or site preparation, and the same for solar. So panels, racking, mounting, and all other balance of plant. So we have the capability in the framework within HOPP to analyze all these different pieces and look at how they behave with different costs, different technical performance parameters, different placement, and in different configurations too, because we're seeing that while the hybrid industry is still pretty new and there's no fixed configuration or platform that everyone is going for. So people really need a way to analyze the differences between these and see what's going to work for them in their situation.
I'm a total geek for the application of artificial intelligence, for example, and machine learning. And I often think of, okay, you have a parcel of land that the landowner is amenable to developing some kind of energy asset on. Energy assets, they produce reliable income for landowners, and that is a very attractive thing. But the challenge is that you have to have good electrical infrastructure, right? You need good substations, access to substations, and you need power lines. Whether those are transmission or distribution, depending on the type of a project. And so I'm just curious, do you guys think about a developer being able to say, okay, here is a an area that I have potential site control over. Here are the assets in the area. Now you go, Mr. Software, and develop a optimized solution, including X, Y, and Z technologies, and give me a solution. You know, I have a use case for this. In Central Illinois, there is a nuclear power plant that is scheduled to shut down sometime in the next 10 to 20 years. Depends on how the state decides to prop it up. Right now, the nuclear industry is receiving subsidies of $200 million a year to keep Clinton and Quad Cities power plants alive. These are nuclear power plants that are approaching end of life. I would love to develop a renewable energy park, so to speak, underneath the old nuclear plant, because there's wonderful infrastructure in this area, right? This is a 2 gigawatt, I think, 1 or 2 gigawatt nuclear plant. Is that something that you guys think about?
Every day. Yeah, I mean, that's one of the core pieces of HOPP. The reason we developed it is to look at things like this. How do new energy systems shape out? How can you replace existing ones or amend existing ones? And it's really a platform for doing that. So that nuclear plant that you mentioned is a perfect use case. You already have your transmission interconnection in place, and a significant amount of it at that. So there's huge potential there to add on to that plant as it's being decommissioned, or finding other uses with wind and solar and storage, especially as they become cheaper. And one of the key things you can do in the HOPP platform is, just like you said, here's our load profile, here's our transmission ability. HOPP will tell you immediately how much wind you should build, how much solar you should build, and how much storage you should build based on the cost and the resource in that location. And then from there, you can dive into the component level build and see what that looks like. And out the other end comes all your financial metrics and your technical performance metrics. One of the things we've been looking at recently is actually not replacement of nuclear plants or amending, but ethanol and H2 facilities. We think that could be a really key place for renewables to play in the future. And so we've looked at the load profiles of those plants based on their greenhouse gas emissions, their CO2 emissions, and offsetting those. What would a plant look like to entirely replace that load? And then what are the economics of that? Say if H2 is your feedstock that's coming out, how much does your electricity cost? And HOPP gives you the framework to model that from start to finish, from a load and location right to your fully designed plant.
Yeah, I'm glad you mentioned H2, because there is definitely a growing drumbeat, and you see this in Europe now, that they are starting to invest en masse in gigawatts of electrolyzers. They're going to be converting natural gas infrastructure to hydrogen infrastructure, and truly creating a hydrogen network. Today, we're years away from this in the United States, probably, but there, you know, I just hosted an interview with a company called Avium, which makes a next generation electrolyzer to produce hydrogen from water. And so we have a plethora of wind and solar energy raining down on us every day. We have 10,000 times more solar than we can use to power society. And I don't know what that statistic is for wind, but obviously there's just a load of energy around us. It's a matter of capturing it and making it a priority to make the clean energy transition. And then we have this phenomenon of all of these aged assets. Here in the Midwest, we have lots of coal and gas facilities that the utilities like NIPSCO, like Alliant Energy, like Xcel are now saying, okay, we're going to sunset these fossil assets. We're going to replace them with wind, solar, and storage. And so there is a growing demand for this. And I'm just curious, what is the timeline for your development? So when is the tool going to be available for use in the real world, in other words?
Yeah, great question. It's available right now. So it's on GitHub. It's publicly available, and there's an open source version of HOPP with almost full features and functionality just sitting there waiting to be used. So right now we have a bunch of examples you can run through to build out hybrid plants and play around with everything you might want.
Cool. And where does where does Homer stop and HOPP start in terms of the scale of the project?
That's a good question. I think that's somewhat flexible, but I think where we start to see utility scale starting is 20 gigawatts and up. And realistically, in our scenarios, we're looking at 100 to 500 megawatts, sorry, 100 to 500 megawatt plants.
So the threshold is 20 megawatts?
20 megawatts and up, I think.
20 megawatts and up. Okay, that makes sense. I know that's what people consider utility scale is definitely a shifting number, and it's going up. But so let's talk a little bit about the various end users, and I'm going to put a slide on screen here in a second. But you're trying to service a very broad spectrum of the industry, which is awesome, but it's also very ambitious. So there's that slide where HOPP adds value. Let's walk us through this.
Sure thing. I guess I can take a shot at this one. So this is basically a very high level timeline of a project from scratch, developing a project from scratch all the way to interconnecting to an existing transmission and going online and pumping the first set of electrons into the grid. So you begin with prospecting and finding the right pieces of land for deploying your particular technology. At this point in time, you can either decide if you want to go solar or wind, and HOPP comes in, and HOPP will help you decide. Well, as you mentioned, Tim, what's given this piece of land is just standalone wind the best option, or if standalone solar, or is it a combination? Well, chances are it's going to be a combination of multiple technologies coupled with storage, depending on the end use as well. So this is where HOPP sort of comes in and tells you, okay, put 100 megawatts of wind, probably 60 megawatts of solar, and 50 megawatts of storage, or whatever, based on that particular piece of land. And then comes the interconnection process. HOPP sort of adds some level of value, but the way we see it, it'll help inform RTOs and ISOs of just how dependable your plant can be, your hybrid plant. And I was sold on hybrids, by the promise of hybrids being green hybrids, so solar wind-based hybrids, serving as base load, but also being dispatchable. And when you combine solar and wind resource together, you get a very high capacity factor. So you're able to actually serve as base load if you design your system right. So if we can somehow prove to the RTOs and ISOs doing system impact study and facility study that this particular proposed hybrid power plant can actually reduce the transmission constraints and actually help unclog some of the nodes in the transmission network of the U.S., then why shouldn't we go hybrids? Why should we not prefer hybrids? So that's where I think HOPP continues to add value on the RTO and ISO side of things. And preliminary engineering also ties into using HOPP to show what's the dollars per kilowatt hour going to look like if you were to do solar only or wind only compared to solar plus wind combination. So you can use HOPP to do a very detailed financial analysis once you've designed a system. So that's where preliminary engineering and pre-feasibility study sort of comes in. And there you have it. I think that's where we think HOPP adds value.
You mentioned in the pre-show that you're involved in a program called I-Core, which I know a little bit about from my contact with the research park here at the University of Illinois. Tell us about what kind of feedback you're getting from industry, that meaning developers and utilities.
Sure thing. I guess some of the feedback that I've sort of start to put together. Well, firstly, corporate procurement of renewable energy is silent, but it's such a big part of the renewable goals that the U.S. has set in 2019. They were close to 50% of the total renewable energy deployed. So we need to start to focus in on what their metrics are for performance. And we've, up till this point, I feel like, focused only on the dollars per kilowatt. Well, corporate procurement of renewable energy, they're not just concerned with the dollars per kilowatt, but a whole lot of other metrics. And I think hybrids sort of are better suited for in comparison to standalone technology. They offer more benefits than just dollars per kilowatt. And I think corporate procurement of renewable energy is headed towards a more hybrid future, firstly. And the current pain point that I see that sort of holds up hybrid deployment is more on the policy side. And how do you get tax benefits for two technologies behind a single point of interconnection? You can either get the ITC for solar in a wind plus solar, or you could get PTC for wind. I don't believe that current policy allows for you to get PTC and ITC for both wind and solar behind a single point of interconnection. So those are some of the main things that we were asked to look into as analysts and researchers from the interviews that we did with industry. And Aaron, please feel free to add. I'm sure there's more.
Yeah, I think you got most of it covered there. I would say we've talked to a diverse set of industry participants, and there's kind of divergence, I think, between the smaller and bigger participants. The bigger participants we've seen are sort of moving into the hybrid space because they see it coming and they can afford to make these plays and just see if they play out. They see obviously the advantages of land use, interconnection sharing, reduced cost, improved performance, but they don't necessarily know yet to a fine degree how that will play out and how profitable it will be for them, but they're willing to take the chance. The smaller industry participants we're seeing kind of almost have to do this, given the cost and the squeeze of the interconnection pricing and duration for that process. They sort of have no choice if they want to compete, but to build their projects as big as possible. And hybrids really give them the opportunity to do that. So they're keenly interested in having tools that let them figure out if this project is going to be viable for them.
You mentioned that the tool is available for download, and I will include a link to the GitHub in the show notes. Mm-hmm. What can a user expect? What is the learning curve, and how long will it take them to get up to speed? And then what kind of support can they expect from NREL, if anything?
Sure. You're looking at the support. So we love interacting with people who are keen to use this software. If you have any questions, you can contact us personally and we will make it work for you. The learning curve could be quite steep depending on your familiarity with Python and Conda environments and things like that. We've tried to make it as easy as possible. The idea was that this is a tool that you can clone from GitHub, get your Python environment set up and just run the example scripts. And for the most part, that's true. And there are 4 example scripts. So we have some wind optimization ones. We have some solar optimization scripts. We have a full example of building a hybrid plant just by supplying wind and solar sizes and seeing how the outputs of that come out. And then we also have a full dedicated single site analysis piece there too. So that kind of covers the gamut of most uses that most people will have. But then, of course, people have different needs or different test cases they'd like to analyze, and we're happy to work with people to implement that functionality or to help you implement it.
When it comes to energy modeling, the backdrop that is so important, of course, is what is the local environment, right? What are the local wind resources? What is the local solar resources? Are you pulling from existing databases for those things?
We are. So you have flexibility here. If you have your own resource information, if you're a developer looking at a particular site, you can supply that. In addition to that, we also have the Wind Toolkit data available from NREL's API, which I think spans roughly 2012 to 2018. And we have a similar time period available for the NSRDB data, the National Solar Radiance Database. So both of those are available. If you supply the lat long, that resource information will be provided automatically for you. So we try to make that as straightforward as possible.
Okay. And then I know one of the strengths is that you can model at the asset level or the technology level. One of the decisions, for example, is, well, which kind of battery storage technology should we use? Is it lithium ion or is it flow battery?
Mm-hmm.
Do you get into those, because those nuances are quite economic and economically driven, and that is, of course, a very dynamic landscape. We're kind of at a fork in the road with batteries. Flow technology is coming on for some use cases. We actually are working on our first flow battery installation in Chicago. Heretofore, it's all been lithium ion. Tell us about that.
Yeah. So on the battery side, right now we're just modeling lithium ion, and we have immediate plans to add H2 and ammonia storage and all sorts of other technologies. It's a very nuanced space. It's changing really rapidly. The technology development in the last 2 years alone has been phenomenal, and the impact on costs that has had has really changed the whole landscape. And I think it's a big part of why we're seeing so much storage deployed with all projects now. So that's something that we're keenly aware of and we want to model. We're not quite there yet. So the dispatch and reliability models play a big part in the economics of the overall storage system. And they're really complicated, really nuanced, and they depend a lot on the actual use case of the plant itself. So that's going to take a little bit more work. Where we're focusing on the component level at the moment is the actual individual placement of wind turbines, solar panels, the interaction with each other, how those collection systems go together, the weight losses that you might experience in different configurations, and the different system cabling and interconnection costs that you might experience with different layouts. But we aim to do something similar with the battery and storage systems that we implement too.
So how many people have actually tried to use the tool so far? Do you have a sense of that?
I think we're probably in the low 20s of people that we've interacted with that are taking this seriously and using the tool. This is sort of a quiet release, if you will. We've told some of the industry participants who've expressed an interest. And while it's available publicly, we haven't really pushed it out or publicized it too much. But it is there for people to use. So,
yeah, I guess just to add to that, as part of like the advertisement, Aaron and I are currently working on a countrywide analysis of how hybrids compare to, given the existing state of technology, how hybrids compare to solar standalone or wind standalone. And we're using HOPP to sort of drive that analysis. So, that will definitely feed into like the advertisement of the tool itself and what developers and all industry stakeholders can expect from HOPP. And that's why we've, as Aaron mentioned, not been as loud about the release, because we want to have a case study or two to show for once we actually do go mainstream with the advertisement.
Let's talk a little more about features and functions, and I'm glad that you mentioned case study, because it really is all about having some real world case studies to show the world, right? Because today, I'm guessing the developers are building their own models for the most part, and maybe kludging together some different technologies, and honestly, the software modeling landscape is quite dynamic. I just had First Solar on the show with their tool called Plant Predict for modeling utility scale solar arrays. They're disrupting PV Syst, which has a death grip on that industry. And I think they're going to be quite successful at that with an API forward technology, a cloud based modern software, which is really the state of the art. So let's just kind of run down your features and functions, and if you can give us some nuance on these elements, that would be greatly appreciated. And as I like to say, this is all about money in, energy out, right? So I'm glad to see cash flow analysis here, because that is kind of the bottom line for most projects, like it or not, right? It is all about ROI for someone. But why don't you guys give us this overview?
Yeah, I think you hit the nail on the head there, is that at the end of the day, the cash flow is really important. I think the nuance to that is, what is the cash flow that that company is considering? Is it dollars or feedstock? So, that could be a pure dollar number, that they have a metric that they need to hit, which is becoming increasingly uncommon, actually. And people are shifting towards other goals, especially with hybrid plants. So really, we have the flexibility to take the energy output and all the costs and cash flow any metric you might imagine. So whether that's annual energy production, net present value, rate of return, LCOE, the conventional ones, or whether it's the cost of H2 feedstock or ammonia feedstock that's coming out of that plant. And all of those are sort of the output parameters that can be wrapped within the optimizing loop of HOPP. So if that's your goal and you make that your output, you can optimize your plant layout, configuration, components, and costing for that. And that moves all the way down to like the individual placement of technology components, their costs, and how they're coupled.
That question about AC versus DC coupling is a perennial question. Also, I recently had Alan Kahn on the show. They are developing DC coupling solar and storage technology for CNI, not utility scale. But can you tell us a little more about that?
Sure, I'd be happy to answer that real quick. When you're considering DC coupling for solar plus storage, it's one thing, but when you add wind to the scene, so you got wind plus solar, for instance, what does AC versus DC coupling mean for land-based projects? Well, there's a AC to DC to back to AC power conversion in the nacelle of each wind turbine. Well, there's current technology that exists that's commercially available that allows you to couple solar in the DC part of the AC to DC back to AC part of the power electronics of each wind turbine. So we're trying to look at questions like, would it make sense to add up to 0.5 megawatt of solar to each utility scale wind turbine, or would it make sense to just couple solar and wind at the substation level at the AC on the AC bus? Will there be any enhancements to performance in doing so? Coupling wind and solar at the wind turbine level or at the substation level, and what will that mean in terms of dollars? Will there be any savings in terms of shared infrastructure? Will there be sharing of wires, for instance, the medium voltage wires going to the substation? And will those savings be enough to make hybrids more attractive? Or just looking at questions like that, just going into the weeds far enough to make sure that we're not going down the wrong rabbit holes when trying to sell hybrids to developers.
Well, what else should our listeners know? I think that your timing is good, which timing is everything when it comes to new technology. And so it is an exciting time in the energy industry in general, right? There is going to be a plethora of hybrid power plants built in the coming decades. And but if you're a developer today, home growing your own tools, what might compel you to start climbing the HOPP mountain, so to speak?
Aaron, or did you want me to answer that?
Go for it.
There's just, oh my God, the only reason I paused is there's so many reasons. Well, back in 2019, more than 100 gigawatts of hybrids were proposed, wind, solar-based hybrids. So we're seeing, despite regulations and policies not being favorable for hybrids, we're still seeing over 100 gigawatts of proposed hybrids in the 2019 interconnection pipeline. So if that's any indicator at all, the future is headed to a hybrid, to a more hybridized future. How can we help industry get there? There's no current, as Aaron mentioned earlier in the call, there's no baseline hybrid system that industry and academia agrees upon. So this is where I think we are trying to set the stage with HOPP, developing baseline hybrid systems. What's a baseline solar plus storage system look like, or what's a baseline wind plus solar plus storage look like? And this is where I think HOPP adds value. You can compare these baseline cases to whatever iteration you want. As a developer, you could consider solar plus storage and compare it with wind plus solar and see if there's any benefits. At the end of the day, it's all about dollars, and with system underperformance being the highlight of 2020, at least for me, based on KWH analytics study, I think hybrids are the solution for reducing underperformance risks and tackling away at land shortages that we were starting to see, at least in the U.S. interior, with wind farms already at scale. All the wind farms, all the lowest hanging wind farms have been taken in the wind belt of the U.S. Well, what's the next step then? You add solar to it, and you take advantage of the complementarity in the resources, and you'll see more of those coming in the future. And we see HOPP as a tool that will help you get to that future.
Yeah. And when you look out, 2, 3, 5 years, what is the plan? Does NREL have a plan for HOPP to truly commercialize it?
Yeah, that's a good question, and I hesitate a little in answering that in too much detail, but we have a couple plans in place for commercializing HOPP in particular, and we've put in proposals with current industry bigwigs for demonstrating the power of HOPP and how HOPP can be used in designing the next generation power plant. So it's in the pipeline to commercialize HOPP, and we've put in some proposals currently this year, and are planning to continue to do so in partnership with industry. I wish I could have spoken more to that, but there is I don't know about a 5-year plan, but for the next 1 or 2 years, we're definitely trying to chip away at commercializing HOPP.
Great. Well, we'll look forward to that, and we'll have to bring you back on the show when you have some use cases under your belt that we can talk about in the real world. I want to make a couple of announcements. We bring you the Solar Podcast interviews twice a week, plus one Clean Power Hour on Wednesdays. I'm going to scroll down to the Clean Power Hour first. Myself and John Weaver break down the latest news on solar, wind, and storage globally, including solar technology, storage technology, and trends like U.S. rejoining the Paris Climate Agreement, right? That's big news. We've done several highlights of floating solar, which is definitely a thing, and lots of stories now on hydrogen and renewable, totally net zero solar panel technology. So that's an emerging trend. And then on the Solar Podcast, tools and technologies like Jake Anderson and Anderson Optimization, which they have developed a very user-friendly land siting tool for solar developers. Check them out. I did a great show with Emily O'Leary at Sunshine Solar. She's a mechanical installer that installed a Gemini 2 in Portrait Next Tracker project here in Illinois. That's the first Gemini 2 in Portrait project in the Midwest. As I mentioned earlier on the show, Alencon and DC coupled storage. So if you appreciate the content, please subscribe to the channel. You can get all of this at cesnrg.com/podcast. Give us a thumbs up, share it with your friends, and please send me suggestions for people and companies to interview on the show, because we truly need to get more and better information out there to our developer friends, to EPCs, and to aspiring energy professionals, whether they're getting into the game for the first time or joining us from some other industry, like the oil industry, for example, right now, which is pretty much tanking. I like to say there is a carbon bubble happening. And so many engineers and field hands are now jumping ship to keep their livelihoods alive. So please join us in the solar industry. I want to thank my guests today at the National Renewable Energy Laboratories, Aaron Barker and Parangat Bhaskar. Thank you so much for joining us, guys.
Thanks so much.
It's a pleasure.
Absolutely.
Thank you to all our listeners. Everybody have a great day. We'll talk to you soon.